when the night wraps around you like a soft blanket and the noise of the day fades into a gentle hush, your mind begins to wander. Where does it go when it's quiet? Maybe far beyond Earth, into the calm and endless dark. Tonight we'll tell you space facts to fall asleep to, slow stories from the universe, spoken gently to help your thoughts settle and your breathing slow. Each one is a step further from the day, deeper into space, and closer to sleep. Close your eyes, breathe in, and let's begin. Fact number 1, the hidden cloud next door, Eos and the dawn of stars. Imagine a vast, invisible cloud drifting silently through space, just 300 light years from Earth. It's called Eos, named after the Greek goddess of dawn. For years it remained hidden, almost ghost-like, too faint for traditional telescopes to see. But recently, scientists noticed a delicate shimmer in the far ultraviolet, a sign of molecular hydrogen glowing in silence. Eos stretches across the sky like a forgotten veil, covering an area 40 times the width of the full moon. And though it's massive, it contains almost no carbon monoxide, which is what astronomers usually look for in clouds like this. That's why it stayed invisible for so long. A CO-dark cloud, quietly waiting to be found. Eos sits on the edge of the local bubble, the vast, empty region in space that surrounds our solar system. And it's important, because inside Eos is hydrogen, and hydrogen is the beginning of everything. Stars are born from it, planets grow around it. Life, one day, might emerge near it. They say Eos will fade in about 6 million years, but for now it drifts near us, ancient, patient, and full of potential. And tonight, it drifts through your thoughts, too. A hidden neighbor, glowing softly as you fall asleep. Fact number 2, the forgotten Soviet probe, Cosmos 482, returns after 53 years. In 1972, during the height of the space race, the Soviet Union launched a spacecraft called Cosmos 482. Officially, it was just another routine satellite. Unofficially, it was meant to land on Venus. But something went wrong. Shortly after launch, the spacecraft failed to escape Earth's gravity. Instead of soaring toward Venus, it got trapped in orbit and forgotten. For more than 50 years, Cosmos 482 has been circling silently, becoming little more than space debris. No transmissions, no noise, just a shell of metal drifting high above us, like a message lost in time. And then, in 2025, something unexpected happened. Observers tracking near-Earth objects noticed a new bright trail in the sky. It turned out to be part of Cosmos 482, breaking through Earth's atmosphere after half a century. A capsule from the probe had survived re-entry and landed in New Zealand, scorched but intact. Think about that. A machine launched by hands half a century ago. Returning home, it carried no data, no mission logs, no samples from Venus, just silence and history. Now, scientists are studying the remains. Its titanium shell, built to endure the brutal atmosphere of Venus, had instead outlived generations of people back on Earth, a monument to forgotten ambition, falling gently back into our world. As you drift deeper into sleep, imagine it, a small, ancient probe returning from nowhere, quiet, charred, and full of stories we never heard. Fact number 3. How plants might grow in space. What we've already tried. Imagine a tiny green leaf opening slowly, not under blue skies, but inside a quiet space station, orbiting hundreds of kilometers above Earth. For decades, scientists have been trying to answer a simple question. Can life take root in space? The answer, quietly, gently, is yes. But it wasn't easy. Back in the 1980s, the Soviets grew the first flower in orbit, a small Arabidopsis blooming aboard the Salyut 7 station. It stretched toward fluorescent light, its roots floating in air, its leaves trembling in microgravity. Since then, astronauts have experimented with wheat, lettuce, mustard, radishes, and even chili peppers. Without gravity, water behaves strangely. It clings to roots in unpredictable ways. Stems don't know which way is up. Light has to be carefully placed to guide their growth. But still, the plants adapt. Some curl, some float, some even thrive. In 2015, aboard the International Space Station, astronauts tasted space-grown lettuce for the first time. Freshly harvested, bright red, and surprisingly crisp. It was more than a snack. It was a symbol, a promise that one day, far from Earth, we might build gardens on the moon or on Mars. Plants are more than food. They clean the air, stabilize the mood, and give us something familiar, a little patch of Earth when we are impossibly far from home. So tonight, as you close your eyes, picture a single green sprout drifting in weightlessness, silent, determined, and growing leaf by leaf into the future. Fact number 4. Why the moon looks bigger at the horizon. The lunar illusion. You've seen it before, rising slowly above rooftops or glowing behind trees. The moon, hanging low in the sky, looks massive, almost too big. A perfect silver coin, close enough to touch. But here's the strange part. The moon isn't actually any closer. It's not larger either. This effect is just a trick of the mind. It's called the lunar illusion. When the moon is near the horizon, your brain compares it to things you can see. Buildings, hills, trees. It feels close, grounded, part of your world. Your mind stretches it, gives it weight, scale, presence. But when it rises higher into the sky, away from reference points, it suddenly seems smaller, more distant, like a glowing marble against an empty backdrop. Some scientists believe it's not just a perspective. It might be the way our eyes and brain process angles. Or maybe it's emotional. The moon low in the sky feels more intimate, more poetic, more real. For thousands of years, people have watched that same illusion. Poets wrote about it. Sailors steered by it. Children dreamed under it. And now, so do you. Tonight, as you drift into sleep, picture the moon rising slowly over a dark, quiet landscape. It hasn't grown, but it feels big, not just to the eye, but to the heart. And that feeling somehow is real. Fact number 5. What NASA's New Mars rover can actually do. Somewhere on the surface of Mars, a small machine is moving slowly across red dust, one careful wheel at a time. It's quiet there. The wind is soft. The sky is pinkish gray. And the rover is thinking. NASA's latest rover isn't just a camera on wheels. It's a laboratory, an explorer, a scout, and a survivor, all in one. It can navigate rough terrain on its own, choosing where to drive without waiting for instructions from Earth. It uses artificial intelligence to avoid hazards, to scan rocks, and to decide which ones might hold the secrets of ancient life. Its robotic arm can drill into stone and store samples for future missions. Small tubes of Martian soil and dust, waiting patiently to be brought back to Earth one day. Maybe in 10 years, maybe more. The rover has microphones. It can hear the whisper of Martian wind, something no human has ever done. It has lasers too, not for weapons, but for science. They zap rocks and listen to the sound the vapor makes, revealing their composition. It carries a helicopter too, a tiny craft named Ingenuity. It flies in thin air where no aircraft has flown before, taking photos from above, scouting paths ahead. It's alone, but it's busy. Far from home, this machine is laying the groundwork for future astronauts, for habitats, for greenhouses, for footprints. It's not just exploring, it's preparing. As you fall asleep tonight, imagine the silence of Mars, broken only by the crunch of wheels, the hum of instruments, and the quiet, steady heartbeat of a rover doing its job, tireless, patient, and always looking forward. Fact number 6, the first moon landing. What really happened in 1969? It was July 20th, 1969. Somewhere televisions were flickering in dark living rooms. Radios whispered static-filled reports. And over 300,000 kilometers away, a fragile spacecraft was descending toward a silent, powdery world. Inside it were 2 astronauts, Neil Armstrong and Buzz Aldrin, holding their breath as they dropped toward the moon. What many people don't know is that the landing almost didn't happen. As the lunar module approached the surface, alarms started going off. 1202, 1201, cryptic codes no one had expected. Back in Houston, engineers scrambled to interpret them. Meanwhile, Armstrong looked out the window and saw that the autopilot was guiding them toward a field of boulders. Not safe. He switched to manual. With less than 30 seconds of fuel left, Armstrong flew the module across the surface, searching for a flat patch of ground. It was quiet, tense, and impossibly delicate. And then, dust kicked up. A shadow formed, and they were down. "Houston," came the words. "Tranquility Base here. The Eagle has landed." Hours later, Armstrong stepped onto the surface and said the words you know. That's one small step for man, one giant leap for mankind. But what the world didn't hear was the sound of his breath, the way the dust clung to his boots, the silence of a world where no sound could travel, only radio signals, only heartbeats. They stayed just 21 hours on the moon, collecting rocks, placing instruments, and leaving behind a plaque that reads, "We came in peace for all mankind." And then they came home. The footprints are still there, undisturbed, untouched, pressed into ancient dust that hasn't moved in billions of years. So tonight, as your thoughts grow softer, imagine those prints under moonlight, quiet, empty, and eternal. Fact number 7. What would it feel like to stand on Mars? Atmosphere, radiation, and cold. Close your eyes and imagine this. You're standing on Mars. The ground beneath your boots is dusty and red, a fine, rust-colored powder that stretches for miles. The air is thin, far too thin to breathe. Your visor fogs slightly as you exhale, and everything is silent except for the faint hum of your life support system. The sky above you is not black, but tinted orange and pale pink, almost like a sunset that never ends. The sun is smaller here, colder, more distant, and the wind is soft but sharp, rushing across the barren landscape at dozens of kilometers an hour, carrying grains of sand that sting, if not for your suit. The temperature, bitter cold, far below freezing even in daylight, and at night it drops even more, enough to freeze steel. You wouldn't last long without protection. And then there's the radiation. Mars has no magnetic field to shield you, no thick atmosphere like Earth's. Every second, particles from the sun and the galaxy rain down. Not enough to burn your skin, but enough to matter. Enough that one day, if we live here, we'll need to build shelters underground or beneath domes. Still, there's something hauntingly beautiful about it. No sounds, no cities, no movement, just stillness. Just the crunch of your steps. Just the feeling that you're standing on another world. A world no human has ever truly touched with bare hands. And above you, hanging quietly in the Martian sky, is a tiny blue dot. Home. As you drift toward sleep, imagine that moment, standing on a red horizon, feeling the silence of an alien world, and looking back at Earth, fragile, distant, and glowing. Fact number 8. How Mars rovers survive, think, and explore on their own. Imagine being alone on another planet. No one nearby, no one to talk to. The sun rises cold over dusty red plain, and the only thing moving is you, a machine, a rover, awake and alert in the stillness of Mars. But you're not helpless. You're not waiting for someone to drive you like a remote-controlled toy. You think. Mars rovers are not just tools. They're explorers, built with enough intelligence to make choices, navigate danger, and carry out science without constant human input. When commands arrive from Earth, it's often too late to react in real time. The signal takes up to 20 minutes to cross the void. So, the rover must be ready. It scans the terrain, measures slopes, checks for rocks or sand traps. If a path is too steep or risky, it chooses another. It watches the sky, tracks the position of the sun to recharge its solar panels, and adjusts its energy usage based on the Martian day. Its cameras are its eyes. Its robotic arm is a geologist's hand. Its memory stores maps, coordinates, and targets. And even though it can't feel the wind or smell the dust, it senses radiation, temperature, texture. In 2021, Perseverance used onboard AI to drive farther in one day than any rover before it, over 100 meters across uncertain terrain, completely on its own. And when night falls, the rover goes to sleep. It powers down, conserves energy, waits for sunlight. It doesn't get lonely. It doesn't dream. But it's there, working, watching, learning. As you fall asleep tonight, imagine it, a small, quiet traveler on a vast, empty world, thinking, listening, rolling forward, one careful wheel at a time. Fact number 10. Where do elements like gold and platinum come from in space? You might be wearing some right now. A ring, a chain, a bit of gold glinting on your skin. It feels precious, rare, timeless. But where did it come from? Not from Earth. Not really. Gold is older than our planet. Most of the elements we know, carbon, oxygen, iron, were formed inside stars. In their final moments, when a star dies in a fiery supernova, it releases those elements into space. That's how planets are born. That's how life begins. But gold is different. It needs something even more violent, something more rare. Gold, along with platinum and other heavy elements, is born in the collision of neutron stars, the densest objects in the universe, just a few kilometers wide, but heavier than the sun. When two of them spiral into each other and merge, the explosion is so intense that it forges the heaviest atoms we know. In 2017, astronomers actually saw it happen, not just with telescopes, but with gravitational waves. It was the first time we watched the birth of gold in real time. After that, the particles drifted, cooled, gathered into dust. Eventually, that dust became stars and planets, and somewhere deep in the crust of the early Earth, it settled, waiting to be found. So that ring, that shimmering dot in a bracelet or necklace, it began in a cosmic explosion hundreds of millions of years ago, forged in fire, delivered by time. Tonight, as you settle under the blankets, think of that. You're not just made of stars, you carry their treasure. Fact number 11. What happens if you fall into a gas giant? Imagine floating above a massive planet, more massive than anything in our solar system except the sun. Below you is Jupiter, or maybe Saturn, a gas giant, swirling, beautiful, mysterious. Now, imagine falling in. At first, the clouds seem soft, like whipped cream stretched across 1,000 kilometers. Bands of color spin below you, orange, white, red. A storm the size of Earth churns in the distance, never stopping. As you descend, there's no surface to land on, no ground, just more atmosphere, thicker, darker, heavier. You fall through ammonia clouds, then water vapor, then deeper into layers of hydrogen and helium. The pressure begins to build. Your body, or even a spacecraft, wouldn't last long. Soon, the pressure becomes crushing. Temperatures rise to thousands of degrees. Hydrogen, once a gas, becomes liquid. And deeper still, it turns into something strange. Metallic hydrogen, a substance that may conduct electricity better than anything on Earth. Deeper again, and you're approaching the core. Maybe a dense ball of rock and metal, or maybe something we can't yet imagine. No probe has ever made it this far. The data fades. The models break down, because no one really knows what lies at the heart of a gas giant. It is one of the universe's quiet mysteries, a place so vast and hostile, and yet so beautiful from afar. So as you sink into sleep tonight, imagine that fall. Endless, soft, slow, down through colors and clouds, into silence, into pressure, into the unknown. Fact number 12. Could we terraform Mars? And what would it take? It's red, cold, dry, and quiet. Mars has always looked a little like home. The valleys, the polar ice caps, the traces of ancient rivers. But if we ever want to live there, truly live there, we'll have to change it. We'll have to terraform it. That means reshaping an entire planet, giving it air, warmth, water, a sky we could breathe beneath. Some scientists imagine giant mirrors floating in orbit, focusing sunlight onto the poles, melting the ice, and releasing carbon dioxide into the atmosphere, thickening it, warming it. Others propose sprinkling dark dust on the ice caps to make them absorb more heat. Still others talk about greenhouse factories, pumping out gases that would trap warmth, slowly building pressure, degree by degree. Over centuries, maybe thousands of years, the surface might warm, liquid water could return, algae could take hold. Later, plants, then maybe forests, one day even oceans. But the truth is, terraforming Mars isn't just a technical challenge, it's a philosophical one. Should we change another world? Should we leave Earth's fingerprint on something that's been untouched for billions of years? Or is this what life does? Reach out, adapt, expand. No one knows the answer yet, but the idea remains, glowing quietly in our imagination. So tonight, picture that future, green valleys on Mars, air gently moving across a planet that was once silent, a second home built from patience, science, and dreams. And somewhere in that future, a child looking up at two moons, wondering what Earth must look like. Fact number 13. The story behind the pale blue dot photo. It's one of the most famous images ever taken. But when you first see it, it seems almost empty. A soft golden haze, a few scattered streaks of light, and there, barely visible, a tiny dot, less than a pixel, pale blue. That's Earth. The image was captured in 1990 by the Voyager 1 spacecraft from almost 6 billion kilometers away. It had already passed the orbits of all the outer planets and was about to leave the solar system forever. But before it drifted into interstellar space, astronomer Carl Sagan made a request. Turn Voyager around. Let it take one last picture of home. What came back was haunting. No continents, no clouds, no people. Just a faint blue speck, caught in a shaft of scattered sunlight, suspended in a beam, like dust in the air. And yet, everything is there. Every moment in history, every mountain and ocean, every family, every war, every poem, every child, every whisper, every hope. Carl Sagan later wrote, "Look again at that dot. That's here. That's home. That's us." It reminded us how small we are, and how rare, how precious a world can be, even when it vanishes into cosmic silence. So tonight, as you lie in the dark, think of that image, the pale blue dot, floating in the endless black. And remember, even the faintest light can carry the weight of everything. Fact number 14. What is the Fermi paradox, and why haven't we met anyone yet? The universe is vast, so vast that it's almost impossible to imagine, filled with billions of galaxies, each with billions of stars, many of which have planets. Some like Earth, some older than Earth, some maybe even better. So, where is everybody? That question is at the heart of the Fermi paradox, a quiet contradiction that haunts astronomers. If the universe is so full of possibilities, why haven't we seen a single sign of intelligent life? It was first asked, casually, in a cafeteria in 1950 by physicist Enrico Fermi. Over lunch, he wondered aloud, "Where is everyone?" And no one had an answer. Since then, people have searched. We have scanned the sky for radio signals. We've looked for patterns in starlight. We've imagined alien civilizations building giant structures around stars, colonizing entire galaxies, or hiding in plain sight. But so far, nothing. Just silence. Maybe we're early. Maybe we're rare. Maybe civilizations rise and fall quickly, like flashes in the dark. Or maybe we're just not looking the right way. Some scientists believe intelligent life avoids contact. Others think we've already been noticed, but we're not ready yet. And then there's the quietest possibility. Maybe we really are alone. But even that silence tells a story about how precious life is, how improbable, how fragile, and how special it is that on one pale blue dot, there's someone, you, wondering about the stars. As you drift deeper into sleep, let that question float with you. If the universe is filled with voices, why do we hear only our own? Fact number 15. How long until the sun burns out? The sun feels eternal. It rises every morning. It warms our skin. It feeds the plants, lights our skies, and anchors the entire solar system. It's so constant that it's easy to forget. The sun is a star, and like all stars, it has a life. Right now, it's about halfway through. Our sun is around 4.6 billion years old. It burns by fusing hydrogen into helium in its core, a process that releases immense energy. But that hydrogen won't last forever. In about 5 billion more years, the sun will begin to run out of fuel. When it does, it will swell into a red giant, larger than Earth's orbit. It will engulf Mercury, Venus, maybe even Earth. After that, it will shed its outer layers, leaving behind a dense, glowing core. A white dwarf, no longer burning, just fading slowly into darkness over trillions of years. But don't worry, there's time. By the time the sun begins to change, humanity, if it still exists, may be living on other worlds. We may have left the solar system entirely, carrying with us the memory of the light that first warmed our species. So tonight, as you lie beneath its invisible glow, remember, the sun you see in the day sky is ancient, but steady. It has billions of quiet mornings left, billions of golden afternoons, and for now, it's here, burning gently, holding us close. Fact number 16, what space-time actually means. Explained simply, time feels like something separate. It ticks, it passes, it flows, and space, that's everything around us, the distance between you and the stars. But what if they're not separate at all? What if they're the same thing? That's the idea behind space-time, a concept at the heart of Einstein's theory of relativity. It sounds complicated, but imagine this. Picture a large, soft sheet, like a trampoline stretched tight. That sheet is space-time. When you place something heavy on it, like a planet or a star, the fabric bends. Other things like comets or light beams move along those curves. Gravity, then, isn't just a force pulling things together. It's the shape of space-time itself, warping around mass. Even time bends, closer to something massive, like a black hole. Time actually slows down. Minutes stretch, clocks tick more slowly. Farther out, time speeds up again. It's not science fiction. We've measured it. Your phone's GPS even corrects for this difference between Earth's surface and orbit. So when we say space-time, we mean the woven fabric of everything, height, width, depth, and time too. A single thing, stretchable, shapeable, alive in a quiet, invisible way. And you, just by existing, are pressing gently into that fabric, leaving a dent, a presence, a path. As you drift into sleep tonight, imagine that, yourself floating in a sea you can't see, surrounded by gentle curves in space and in time. Fact number 17. How do we know the universe is expanding? The night sky feels still. The stars seem fixed like tiny holes in a vast, unmoving ceiling. But the truth is more surprising and more beautiful. The universe isn't just sitting in place, it's growing. We know this because of something called redshift. When we look at distant galaxies, their light appears stretched, shifted toward the red end of the spectrum. It's the same effect you hear when a siren passes by and changes pitch. The sound stretches as it moves away. Galaxies are doing the same thing, but with light. And the farther away they are, the faster they seem to be moving from us. It's not because we're at the center. It's because space itself is stretching in all directions. This discovery was first made in the 1820s by Edwin Hubble. He noticed that every galaxy, almost without exception, was retreating, not drifting through space, but carried by it, like raisins in rising dough. And here's the wonder. If the universe is expanding now, that means long ago, it was smaller, more compact, which leads us to the Big Bang, not an explosion, but a beginning, a single point from which everything stretched outward. Time, matter, light, all of it. Even now, billions of years later, space is still expanding, quietly, softly, beyond what we can see. And you, lying still in bed, are drifting too, gently, silently, through an ever-growing universe. So tonight, as you sleep, imagine that motion, galaxies blooming like flowers, space unfolding like silk, and the whole cosmos breathing in slow, endless rhythm. Fact number 18. Where does a black hole go? What's beyond the event horizon? Somewhere far away, or maybe not so far, a star has collapsed. It's no longer burning, no longer shining. It's fallen inward, crushed by its own gravity, until nothing could stop it. What's left is a black hole. From the outside, it looks quiet, simple, a dark sphere floating in space. But at its edge, something strange happens. A boundary called the event horizon. It's the point of no return. Cross it, and you're gone. Not torn apart instantly, not exploded, just erase. No signal can escape, no light, no information. And that leads to a haunting question. Where does everything go? Inside a black hole, all our physics begin to break down. Space and time themselves twist. The core, what we call the singularity, is a place where gravity is infinite and the known rules of reality vanish. Some theories suggest that everything falling into a black hole is crushed into that point forever. Others wonder if black holes could be portals to other places, other dimensions, or even other universes. There's also the idea that the information isn't lost at all, that it's stored somehow in the surface of the event horizon, a kind of cosmic memory written in the fabric of space. We don't know yet. Maybe we never will. But black holes aren't monsters. They're not evil. They're simply gravity, taken to its extreme. And even they, over trillions of years, will fade, evaporating slowly into nothing. So tonight, let your thoughts fall gently, like stardust, toward the edge of the unknown, not with fear, but with wonder, because sometimes, even in the dark, the universe is still listening. Fact number 19. How big is the universe, and could it be infinite? Stand outside on a clear night and look up. The sky seems endless, but how big is it really? The observable universe, the part we can actually see, stretches out about 46 billion light years in every direction. That's not because the universe is only that old. It's because space itself has been stretching, expanding faster than light can catch up. So what lies beyond that edge? We don't know. Maybe just more galaxies. Maybe something stranger. But here's the astonishing part. There's a real possibility that the universe is infinite. No edge, no center, no boundary. Just more. More stars. More space. More time. More everything. And in that infinity, Earth is smaller than a grain of dust. Your body, a flicker of molecules. Your life, a blink. And yet, here you are, thinking about it, part of it. Some scientists imagine the universe as a closed loop, like the surface of a balloon, finite but unbounded. Others think it may go on forever in all directions, with no repeating patterns, no familiar edges. And beyond even that, there may be other universes, a multiverse, bubbles of reality floating in something even larger. It's overwhelming, it's humbling, but it's also beautiful, because no matter how vast it is, your thoughts can still reach it. Your questions can still stretch into that darkness. And even as you lie still, your mind moves outward, endlessly. So tonight, let it drift. Let your dreams stretch into that great silence, into the stars beyond stars, into the possibility that there may be no end at all. Fact number 20. What if Earth had rings like Saturn? Close your eyes and picture the sky, not empty, but glowing. Not just stars, but giant arcs of light stretching from horizon to horizon. Pale gold, soft silver, a halo wrapped around the Earth itself. What if Earth had rings, like Saturn? It's not impossible. In fact, some scientists think Earth may have had rings long ago, formed after ancient collisions, then lost over time. But what if they stayed? The rings would hover above the equator fixed in the sky. If you lived near the poles, you might barely see them, just a sliver. But closer to the equator, they'd be breathtaking. Bands of ice and rock, thousands of kilometers wide, glowing with reflected sunlight. Cities would be built facing them. Cultures would grow up beneath their shimmer. Art, mythology, even timekeeping might change. Nights would never be truly dark. The moon might pass behind the rings or cast shadows through them. Eclipses would become layered events. Sunlight, moonlight, ring light, all overlapping in quiet choreography. But there would be trade-offs. Rings would block satellite orbits. Space travel would be harder. Their debris could threaten stations or even fall into the atmosphere. They'd shape not just our skies, but our technology, our ambitions. Still, the beauty would be impossible to ignore. So tonight, imagine Earth with rings, the way Saturn wears them, elegant, silent, suspended above the clouds like a crown of frozen light, and somewhere beneath that glow you, looking up. Fact number 21. The sound of a black hole, how we heard it in B-flat space, is silent. There's no air to carry sound waves, no wind to whistle, no ocean to roar, just vacuum, just light, just silence. And yet, in 2003, scientists at NASA did something extraordinary. They heard a black hole, not with microphones, but with math. Deep in the Perseus galaxy cluster, 250 million light-years away, lies a supermassive black hole. Around it, clouds of hot gas, dense enough, massive enough to vibrate. Those vibrations rippled outward in slow, deep waves, pressure waves, technically sound. The note they detected was a B-flat, 7 octaves below middle C, far too low for human ears. A sound so deep it would take millions of years to vibrate once, but it's there, still echoing, still humming, like the bass line of the cosmos. Years later, NASA used data from other telescopes to sonify black hole activity, translating energy patterns into sound humans can perceive. The result? A haunting melody, rising and falling almost like a voice, a whisper from gravity itself. Black holes don't just pull in light, they shape the space around them, the time, and maybe, in their own way, the music. So tonight, as everything grows quiet, imagine the sound beneath silence, a note stretched across galaxies, a black hole singing not in chaos, but in harmony, and somewhere in the stillness of your room, that sound, impossibly deep, impossibly slow, hums softly in your dreams. Fact number 22. Could there be oceans beneath the surface of distant moons? Not every ocean reflects sunlight. Some are hidden, locked beneath ice, tucked away on silent, frozen moons, orbiting distant planets. Places like Europa, a moon of Jupiter, or Enceladus, orbiting Saturn. On the surface, they look like snowballs, white, cracked, lifeless. But beneath that crust, something stirs. Liquid water, oceans, vast and deep. We know this because of tiny signs, geysers erupting from cracks, spilling water vapor into space, magnetic fields wobbling strangely, hinting at salty seas below, heat radiating from the inside, enough to melt ice, even this far from the sun. Enceladus, no larger than the state of Arizona, shoots plumes of water hundreds of kilometers high. NASA's Cassini probe flew through one. It tasted the spray. Inside, complex organic molecules, the building blocks of life. Europa too may hide an ocean twice the volume of all Earth's seas. Under kilometers of ice, there could be warmth from tidal forces, minerals from the rocky core, a gentle darkness where life might begin. Not life as we know it, not fish or whales, but perhaps something simple, alien, waiting. It's a haunting thought that in the coldest places there may be warmth, in the darkest places a chance for life. So tonight, let your thoughts sink gently downward, beneath ice, beneath silence, into a world lit only by chemistry and pressure, a sea without sunlight, but not without wonder. Fact number 23. How would it feel to watch Earth rise from the moon? Imagine standing on the moon. Beneath your boots, the ground is gray and silent, a desert of dust and shadows. The sky above you is black, even in daylight. No atmosphere, no breeze, just stillness. Now look toward the horizon, and rising slowly, impossibly, is Earth. Not the moon in your sky, small and silver, but Earth, full, round, glowing blue and white, oceans swirling, storms drifting, continents you could name from here. It happens because the moon doesn't rotate the way Earth does. From most places on its surface, the Earth just hovers, fixed in the sky. But from a spacecraft in orbit around the moon, like Apollo 8 in 1968, you can see something breathtaking: Earth rise. It was astronaut Bill Anders who captured the famous photo, a blue marble lifting above the lunar limb, wrapped in cloud and light. He later said, "We came all this way to explore the moon, and the most important thing we discovered was the Earth." That moment changed how we see ourselves. It made our planet feel fragile, united, alive. No borders were visible, no politics, just one world floating in darkness. So tonight, close your eyes. Imagine looking up, not at the moon, but at your own home. Rising slowly into view, not as a map, not as a globe, but as a single shimmering miracle, small, spinning, shared. Fact number 24. What happens to time on a space station? Time feels constant, steady, familiar, but up there, in orbit, circling hundreds of kilometers above Earth, time bends, just a little. On the International Space Station, astronauts orbit the planet every 90 minutes. They see 16 sunrises and sunsets in a single day. And though their clocks tick almost the same as yours, they don't tick exactly the same. Because of Einstein's relativity, time behaves differently depending on speed and gravity. The faster you move, the slower time passes for you. The farther you are from a planet's gravity, the faster time flows. So, in orbit, where astronauts are moving incredibly fast and are slightly farther from Earth's gravity, they experience time just a touch differently. Each day, they gain about 0.1 seconds compared to people on Earth. It's barely noticeable, but it's real. So real, in fact, that GPS satellites must constantly correct for these differences, or our maps and navigation would quickly fall apart. Time isn't rigid. It flows, stretches, bends, depending on where you are, how fast you move, and what surrounds you. So picture an astronaut floating softly in the cupola of the space station, watching Earth spin silently below, everything moving, everything glowing, and around them, time slipping just a little bit slower. Tonight, as your own time slows into sleep, imagine yourself there, weightless, drifting, watching the hours pass not with numbers, but with light, sunrise, sunset, earthlight, dreamlight. Fact number 25. Could a star live for 1 trillion years? What are red dwarfs? Not all stars burn bright and fast. Some live slow, quiet lives, glowing faintly in the dark for billions, even trillions of years. These are red dwarfs, the most common type of star in the universe. Small, cool, steady. If our sun is a blazing campfire, a red dwarf is a candle, gentle but lasting. They burn hydrogen with incredible efficiency, while large stars use up their fuel quickly and die in dramatic explosions. Red dwarfs stretch their lifespans across unimaginable time. The smallest of them could live for 1 trillion years. That's over 70 times the current age of the universe. In fact, no red dwarf has ever died. Not yet. The cosmos simply isn't old enough. That means, in the distant future, when all the bright stars have faded, when galaxies have grown dark and silent, red dwarfs will still be shining, slowly, faithfully, lighting the last chapters of the universe. Some of these stars have planets. Some of those planets are in the habitable zone, not too hot, not too cold. And though life around a red dwarf would face challenges, like solar flares and tidal locking, it's possible that someone, someday, could call such a place home, a quiet world around a quiet star. So tonight, let your thoughts drift toward the far future, past everything we know, into an age of deep time, where little stars still flicker, still warm, still shine, not loud, not fast, but lasting.